Hi, everybody. I'm Travis Green, Product Manager on the Petition API. We're here to talk to you today about smart application design. But first, I want to do a little survey of the audience. So how many of you have ever built or wanted to build a recommendation system for one of your applications? Not bad. OK. I got a hand wave up here. How many of you have ever wanted to do sentiment analysis in one of your applications? Okay. How many of you have ever had to do something really repetitive to make one of your applications work? OK. So we're here today to talk to you about how you can stop doing some of those more repetitive things. There we go. So first, we should think about what is a smart application. The screen here shows you 3 themes that we talk about and some examples of smart applications. I'm going to walk through each of them. Then we'll move into talking about how all these sorts of things work. Then we'll show off how the Petition API works. My colleagues Max and Robert will give a demo of a live coding demo of how the system can be built from scratch. And then Jóhannes and Ryan over there from Forward will talk about how they've been using the API. And then we'll talk about some of the really cool things that we announced yesterday and show them off to you. So first, what is a smart application? We think about smart applications at the Petition API team as things that automate the repetitive, extract the essential, and recommend the useful. So things that automate the repetitive are things like content moderation. So let's imagine you're running a blog and you have a forum on that blog. And you get a lot of spam, say spam about certain drugs you don't want to see on your blog. Filtering those out is really frustrating and really complicated because sometimes the patterns that you'll be seeing from that spam will change. And so the Petition API, you can go and you can say, well, I have all this data that I've used in the past, so I have labeled all these comments as things that should be posted or things that shouldn't be posted. And I can take those lessons and apply them to new comments coming in. So I can say, all right, well, the ones that score very high are automatically posted. The ones that score very low are automatically rejected. And the small group in the middle, I will look at myself. So now moving on to things that extract the essential. A great example of this is Gmail's priority inbox. It takes the patterns that you have shown by looking at messages over time and then applies those patterns in incoming messages so that you can see the most important ones right at the top. Now, things that recommend the useful. The example on screen is an apps recommender written by one of the developer relations people here at Google that takes certain characteristics about a business. You fill out these 5 questions, and then it predicts applications you're most likely to be interested in. That's a very simple form, but you can imagine things getting much more complicated. Some of the more complicated things would be things like Pandora, which gives you an infinite stream of music from pieces of music people have liked, and also things that are the intrinsic characteristics of the music itself. Another example, this team's from New York, so we always are trying to get cabs late at night. And one of the great applications in New York is called CabSense, which, depending on where you're standing in the city, will look at all of the cab rides for years, millions of cab rides, and tell you which corner to stand on to catch a cab most quickly. So you can think about these sorts of applications as being the forefront of a new generation of applications. But we're left with the question of how do you build these things? They may seem like magic on the front, but there's got to be something behind them. So machine learning is a great way to do this. It's something that many people seem to think you need a PhD in statistics or a PhD in complex mathematics to do. But we make it really easy. So the screen here shows you just conceptually how all that works. You take a set of inputs, a set of examples, look at them, see what things have indicated a certain kind of behavior, learn patterns, and create a model of that input set, and then use that when you have a new example coming in to predict characteristics about it as an output. So now this slide shows you how the Petition API makes that really easy. We talk about 3 simple HTTP calls. The first being that you want to upload upload data for your predictive model to learn from. Then you say to the API, well, I want to train a predictive model from my data. So then we go out and we apply many different algorithms to try to find the best possible one. Then when you have a new example come in, say a new piece of text you want to know the sentiment of, or a new user who you want to recommend different content to, the system will then apply the lessons it's learned, the patterns it's learned, to that new example and show you an output that indicates what sorts of content that user is interested in or what the sentiment of that specific post is. Now, this system was available to preview developers before yesterday. So we're very, very happy to announce that all of you here and everyone across the world can try it out. We are both offering a free quota for anyone to try out the system, and then also an SLA for users who want to make bigger applications. And that will be a paid tier. So you can see that we have a 3.9 service level agreement. That is to ensure that you guys can be sure you can depend on us, that the system will always be there when you need it. Thank you. I'd like to now turn it over to Max and Robert, who will show you with some live code how you can build one of these applications yourself.
Hi, everyone. My name is Max Lin. I'm a software engineer on the Petition API team, and this is my colleague, Robert. So as Travis said, that today at the I.O., we're going to make this Petition API generally available. So what does that mean to you? That means everyone inside this room and also the people seeing this presentation through the video, you can sign up right now and use Petition API to make your apps smarter. So let me show you how easy you can sign up the Petition API now. So we are going to use a tool called Google APIs Console. So in case you haven't noticed, this is a new like a one-stop place for you to use various Google APIs. So here I'm going to show you, you can go to Google APIs Console, go to the URL on the screen. It's code.google.com/apis/console. And so let me just show you how you can sign up Petition API. So for the first time, you go to APIs console. On the screen, you will see a list of APIs, and Google Petition API is one of them. So how do you sign up? And sign up is pretty easy. It's just one simple mouse click. And if you go to Petition API, yeah, and you click, and they become on, and then you can start to use Petition API. Just one simple mouse click you can use. On the top, you will see a yellow bar, kind of reminds you to sign up Google Storage for developers. I'm going to explain to you why you need to sign up this. And in a very simple sense, Petition API is all about learning from historical data. And how do you pass the historical data to Google Petition API? You upload the data to Google Storage. Google Storage is a storage service running on the cloud. And again, it's very easy to sign up Google Storage for developers. If you scroll down, you will see storage is there. And it just, again, single mouse click, and you can sign up Google Storage too. And that's it. We already signed up the Petition API, and we are ready to start to use. So for the following presentation, I'm going to give you running examples of monitoring social media. So suppose you are a company and you are interested in various social media, and you are interested, like for me, I like 3 topics. So whenever people mention App Engine, Android, or Chrome, I want to automatically detect that and try to kind of give me an alert. So how do you do that? So you can imagine you have some input and you want to generate some output. An input here will be a piece of text. So it's a piece of text you find on a social media. And what's the output we want? We want to automatically detect this piece of text is about App Engine, Android, or Chrome. That's what we want. We want some output in 3 categories. So how do you do that? So imagine you sit down, you want to write this function, a very simple input and output mapping yourself, which is pretty hard because it's hard to figure out the rules. The rules can be complex. So I'm going to show you how you can use Petition API to learn the mappings using machine learning technologies we use internally at Google, and we open it up as a Petition API for you to use. And hopefully you can leverage this Petition API to make your app smarter. So the first step is called upload. And this basically boils down to collect a bunch of examples. And those examples, as I show on the screen, in the middle, you will see 2 lines in a very simple, common separated value format. And 1 example per line, And in the first line, you will see the first column is hashtag App Engine, and the second column is a piece of text, the Python library for hosted SQL. So one example per line, and you collect as many examples as you can. So what do we want to do this? We basically collect historical data, how people talk about App Engine, Android, or Chrome. We collect as many examples as we can. So you put these examples as a file. So you see here, we save this one examples, two examples, and many, many examples in a file. And it's a very simple CSV format. And how do we pass this file to Google Storage? We are going to show you use a very simple tool called gsutil. And this tool is just one of the many tools you can upload file to Google Storage. And I'm going to show you, this is a command line tool called gsutil. And we do CP. I'm going to copy the training file, my data. And this file consists of many, many lines of the social media text talking about App Engine, Android, or Chrome that we already know for sure. Then we upload to Google Storage, and the syntax is gs://io11. And io11 just a bucket. It's the way how Google Storage organizes your files. And inside this bucket, we are going to call this file /mydata. And that's it. Let's run it. And so what happened behind the scene here, you see, is the file, the historical data about the social media, actually copy from this laptop to the Google Storage in the cloud now. And that's it. That's just a simple first step. You collect a bunch of data, you collect historical data, you upload to Google Storage. So let's look at the second step. It's called training. And in this step, we want to tell Petition API, hey, go over my historical data, learn the mappings between inputs and outputs. And it may sound simple, but behind the scene, we do a various optimization and use the technology we use internally at Google. We run that and run many, many different machine learning algorithms and pick the one that's best for your own data. And so how do you interact with Petition API? So in the middle, you will see it's a simple HTTP call. So Petition API is a RESTful service, and the way you interact with Petition API is through the network, through the HTTP protocol. So here, in order to ask Petition API to start a training, you make a pause call. And the UI is pretty simple. It's just petition/v1.2/training. And inside the body of this HTTP pause call, you specify the name you just upload to Google Storage. And that's it. You just tell Google Petition API to start a training job and look over this historical data. And you specify in the body of the HTTP call. And the training is running asynchronously. So when you make a call, a training starts. And it depends on the size. It can take a while. So how do you know the training is finished? In order to know the training is finished or not, you make another get call. And the syntax is very similar. It's still a URL. And instead of pause call, you make a get call. So let me show you how we can actually do the training right now using a tool called Google APIs Explorer. So just in case you haven't seen this, it's a web app for you to explore various Google APIs. So Google Petition API is one of them. So when you the API Explorer, on the first column, you will see a bunch of different Google APIs. So you click Petition API. Right now, our version is v1.2. That's shown in the second column. And the third column is the various methods Google Petition API provide. So every row is one method. You can try it out. So if you want to try it out, say we want to make a training call. Let's try the training.insert. So you click training.insert, and you can start to fill the body. So here we want to make a training call against the file of your historical data we just upload to. So inside the body, we open up this text, box, and we type the input in JSON format. And there's only one field you have to provide. It's the name of the historical data you upload to Google storage. So here it's io11/my-data, and that's the name we want Petition API to look at. That's it. So let's just make this call right now from the Google APIs Explorer. And at the bottom, you will see this is the response returned by Petition API. Again, on the top request, you will see it's a simple post call to the URL you see on the screen. At the bottom, the response section, you will see that's the response returned by Petition API over the network to the API Explorer. So the response, the first you see is 200 OK. That's HTTP status code. So that means our call is successful. And at the bottom, you will see the response body is JSON. And you will see return the kind and what's the ID. And everything looks fine. So that means our training already starts. And it starts in the background running in the cloud. And Petition API start to parse your historical data running multiple different machine learning algorithms and try to learn the relationship in your data. And that's it. You finish the second step, the training step. Now let's look at the third step called predict. And this is probably the most frequent step you are going to do in your applications. And this step, you get a new piece of text, a new piece of inputs, and you don't know the category. And in our case, we don't know, we want to predict, we want to identify this is about App Engine, Android, or Chrome. So we want to make a prediction against this new piece of text. So again, in this, the syntax is similar, and it's still one URL you have to call. And you have to specify the name after the, so if you read the call, it's post prediction /1.2. training /io11 my data, and that's again, it's the same file name you upload to Google storage. After that, you append the predict. That means you want to make a prediction against that particular sets of historical data. So inside the body, we specify the new piece of text we want to make a prediction. So here, the body, again, is in simple JSON format. And you have to only specify the new piece of text in a field called, the ID is it's called CSV instance. CSV stands for Common Separated Value Instance. And inside that field, you populate the piece of text you want to send over to Petition API over the network. So here we just have an example, what's the smart Android app. So that's a new piece of text. You don't know what they're talking about, but you want Petition API based on your historical data and make a prediction and return what's the most likely hashtag or category it's about. And here I give you an example of a categorization, and Petition API also support regression. And by regression, we mean if you want to predict something, it's real valued. So here, for classification, it's all discrete category, App Engine or Android or Chrome. But for regression problems, you want to predict something with real values. Like given the people's height, you want to predict their weight. And weight is not discrete. Weight is a continuous numbers. And Petition API also supports that. So I'm going to show how we're going to make a Petition API call, the petition call, in a simple web app demo. So I've been talking about monitoring social media. So this is a very simple web app. We're going to make this source code available, so don't worry about that. And inside this simple web app, in the middle you see a text box. And that piece of text box is we are going to type some text. And when we click the predict button, we are going to make a petition call to Petition API. We are going to pass the text inside the text box over the network to Petition API. When we get a response, we are going to show the result on the right of that predict button, in the blue, you see right now a tag there. And that's the response we get from Petition API. Before I show you the codes, I just want to have a quick of hands. How many of you have written any web apps before? Okay, I see a lot of you. How many of you have written any JavaScripts? Okay, I see pretty much almost all of you. For those minority in this room, don't worry. So I'm going to show you the examples in JavaScript, but underlying Petition API is a RESTful service. So we also provide Java libraries, Python libraries, Ruby libraries. So don't worry about JavaScript. This is just one example, but Petition API can be called from many, many kind of libraries because underlying is all HTTP code, and they can be called from pretty much every programming languages you want. So let's bring up the HTML. And so here, the first step you need to do is to include the JavaScript library, which also we announced today. And this JavaScript library, the way to use it, just include that. And you can see highlight here. It's just one simple HTML you have to do. You just add this one line, and you include the JavaScript library for a Petition API. Now let's look at the JavaScript. So you will see on the screen there is a function called predict. And this function, this JavaScript function, is going to be called when we click that predict button. So I'm going to show you how easy to use JavaScript to make a predict call in just one single line. So here, as you see on the screen, it looks like 4 lines, but it's just one simple function call. And if you look at this function call, the name of the function is called prediction.predict. And if you remember, we see this in the API export, that's the same name there. And this function is just one single function you need to call. And inside the body of this, the arguments, you just provide 2 ingredients. First is the name. Again, it's the name of the historical data you upload to Google storage. So here we put io11/mydata. And the second argument is the input. And this input, again, is the new piece of text you want to send to Petition API and want to make a prediction against it. So here on the screen, you see we get this piece of text from a particular HTML element. But it's easy, very easy for you to adapt this. You just grab whatever on your web app and put it inside this CSV instance field, and you can send this piece of data to Google Petition API. So at the end, when response is returned, we are going to call a callback called prediction callback, as we highlight here. And this callback is basically a JavaScript function. And inside that function, we just update the web page. So let's save this file and see this in action. So we're going to save this JavaScript file, and we go back to our web app, and we were going to reload the page. So remember, all we do is just include one line, and we include the JavaScript library, and we add one function call to make a prediction. So let's type something in a box. Say I gave my mom a new Nexus S phone for Mother's Day. So this is a new piece of text we get from social media, and we want more Petition API to look at, based on relationship on our historical data, and try to predict this is about Android, App Engine, or Chrome. So let's hit the predict button. Ooh, so now it works. It's Android. So, and this Android is, as you can see on the input, there is no word like Android there. But if you, based on your historical data, if you collect enough examples, and you Petition API can try to figure out why this piece of text is about Android. So let's try something else. Where can I find, say, extensions for educators? So I'm a teacher, I want to find Chrome extensions. Okay, let's send this piece of text to Petition API. Oh, so now you see the update is now Petition API. I think based on your historic, this is most likely a cron, and you return this is a cron. This is belong to the category cron. So I want to remember that all we do is just add one include source code in our HTML, and we add just one function using JavaScript library. So I hope every one of you here can start to think, how can I make my app smarter? How can I make my web app smarter? Because it's very easy to use. So now you as a developers, it's in your, you should think that you have this tool at your hand, and it's very easy to use, and you can start to make your app smarter. And this is not just about JavaScript. We have a Petition API offers different kind of libraries. So it doesn't matter you are writing Android apps or desktop apps. It doesn't matter your apps running on Android or tablets or TV or even in the Chrome. It's everything. Once in the cloud, you can make a petition call over the network. You can use Petition API. With that, I'm very happy to have Ryan and Jóhannes from Ford Research and to tell you how they can use machine learning and Petition API to make cars smarter.
So as I mentioned, I'm with Ford Research, and we're using the Petition API to do some interesting things with our vehicles. So Ford's been connecting drivers with their vehicles for some time now using our sync system. And the next step, which we're going to talk about today, is to connect the vehicle to the cloud. And we think that's going to open up all sorts of interesting possibilities. The cloud's going to give us access to real-time data, such as traffic and weather. It allows us to leverage large-scale computation capabilities. And if we take that and couple it with some intelligent machine learning, what we can do is really develop personalized control systems that are going to be optimized for your individual driving habits. The application that we're talking about today is a plug-in hybrid. Now, a plug-in hybrid is an extension of a normal hybrid vehicle with two key differences. First, it has a much bigger battery. And secondly, you can recharge that battery using the electric grid system. Now, you need to imagine a future where there's some geographical areas that have been defined. Maybe it's your neighborhood. Maybe it's near a school. And maybe it's a government that's defined this area. In fact, there was an article in the New York Times earlier this week about the French government looking at this for some of their biggest cities. And the idea is that this area, you want to limit your engine. You want to try to drive as an electric vehicle in those areas. So our job is to save energy so that when you get there, you can operate that vehicle as an electric vehicle. So let's talk about a use case. I go down in my car, it's Tuesday, time to go home. The car says, "Good afternoon, Ryan. Are you headed home?" And I say, "Yes, I am." And it says, "I noticed there's an EV driving zone along your route. Would you like to save some energy for it?" And I say, "Yes, that'd be great." So how are we going to do this? Well, as you can guess, we're going to try to make use of this Petition API. And what we do is we have driving history. So this is the personal data about how you use your car. Then, using that, the Petition API is going to build a model, and we're going to ask that API a question. We're going to say, where is this driver going to go to next? And then once we know that, we can optimize the powertrain for that specific route. So now I'm going to turn it over to my colleague Jóhannes, who's going to take a look under the hood and try to explain exactly how we're doing this. There we go.
So before we can make any prediction, we need to have data to predict on. And since we are going to predict where you will be going, we need to know where you've been. To get that data, we've asked a few of our colleagues to install data loggers on the vehicles. Data loggers record the vehicle's position, GPS positions, date, time, and other important vehicle parameters for us. Once we've collected that data, we analyze it to identify the locations for each trip, the origin, the destination, the time the trip started, and the date. We then reformat this into a format that's suitable for prediction. That means that we take the locations and convert them to tags, and we take date and time and make them scalar variables. We then upload everything to the cloud, just as shown for us. This is our prediction research platform. It contains the same functionality as we have in our prototype cars, but allows us to see what's going on behind the scenes. The first thing that happens is that the vehicle receives a GPS position. And since GPS reception in here is pretty bad, I will manually inject a position that corresponds to my own home. Say 6:45 in the morning when I'm normally heading to work. The application will take this information, identify that this belongs to a location for me home. And since the GPS also contains information about date and time, we have everything we need in order to make a prediction. We ask the Google Prediction API for a categorization request, namely to which location tag does this input data belongs. As shown here, it detects that I'm going to Ryan in the morning, which is pretty true since I'm carpooling with him. Knowing where we are, knowing where we're going, we can also calculate the route, and we cross-reference that with a list of our EV zones in order to create an optimized strategy for how to drive this route, as Ryan just told us. Now, everybody's not 100% predictable. It's great that you predict where you're going, but there might be alternatives. For example, this application now believes that days when I'm not carpooling with Ryan, I might be working from home from somewhere else. And just as that, I can get an optimized strategy for that route. This is a research platform, so I can also change my input variables. Say that I want to see what I'm doing on a Sunday morning at 10:30. And a new question is generated to the Google Prediction API, and directly I get an answer back and can act on that.
Thanks, Jóhannes. This isn't vaporware. This is actually Jóhannes and I driving the prototype vehicle just last week around the Ford campus, proving out this technology. So where do we want to go next? Well, our own driving habits change over time, so it's important that these models that we're having to predict future behavior are going to change over time. So that's one element we want to work on. And then secondly, this EV driving zone is just one example about how we could use this technology, but we have a whole list of other ideas that we're pursuing also. And then taking it back to the big picture, really what we want to do is use the cloud to empower the car, to make it smarter. And the intersection of connectivity and powertrain electrification, I think, is really ripe for innovation. And the Prediction API is just one step to really unlock that technology. Now I'd like to turn it back over to the Google team.
Hi, everybody. I'm Robert Kaplow. I'm a software engineer with the Google Prediction API. And I'm really happy to be here today to talk to you guys about some of the cool stuff we've been working on. I want to thank Ryan and Jóhannes from Ford Research, who are here showing you guys some of the cool uses they've been making with the Prediction API. And hopefully, looking at this kind of stuff, you guys can get some ideas, some of the really cool things you guys can do in your own applications. So Max has been talking to you about the current paradigm for the Google Prediction API. You gather a bunch of data from your users. You put them into Google Storage, store them on the cloud. You train a model, and then you make predictions on it. And for a lot of people, this is great. You actually have this big batch of data up front, which you want to make predictions on continuously. But a lot of people have been asking, what happens if my data is changing over time? I'm constantly getting new data in. And right now, what you have to do is actually take the new data, put in common separate value format with the old training sets, and retrain. And then you can take newer, fresher predictions. But a lot of people get data in real time. They're running their applications on the web, on mobile devices. And users are buying products and clicking on links. And your application is getting tons of data just flowing in. And what you'd really like is a way to have a predictive model that's actually going to respond in real time as your users are changing and as your data is changing. And so today we're really happy to announce we're launching a new feature called streaming training. And this is going to allow you to add real-time data to your predictive model. So this is a new API feature. It's implemented as a RESTful HTTP call. And the best way to think of it about this is it's an update to your predictive model. So you're not retraining from scratch. You're taking your current predictive model, adding a new batch of data, and then it's going to be updated. So you can imagine there's a few advantages of using this. First off, it's going to quickly adapt to new data. So say you're doing categorization of hashtags of the conference, so like App Engine or Chrome. And all of a sudden, people are doing hashtags of a new track. And you really want to be like, OK, I want to be able to categorize this very quickly, too. And using the streaming training, you actually are able to categorize this new information without having to manually update your model. A second reason you may want to use this is this will automatically improve performance over time. In machine learning, the more data you have, the better. The more data there is, the better reflection it is upon the real world. If your data is sparse or it's missing pieces, it won't necessarily do as well. So even if the underlying world isn't changed, and even if there's no new categories and there isn't much change in the underlying thing you're trying to track with your predictive model, if you're just adding more data as it comes in as quickly as possible, this is going to make your model as fresh as possible and let you apply the freshest predictions. So this isn't really, we'd like you to think about this as an alternative way to train predictive models. We're not deprecating training. In a lot of cases, you actually may have a fixed amount of data up front which you can train and do predictions on. And that's great. If that works for you, then we definitely recommend it. But if you have a use case where you're actually getting a lot of data in real time, in an application, in a web app, in a mobile app, in a desktop app, and it's constantly coming to you, we really recommend you try using streaming training. So let's look a little bit more at how streaming training is actually implemented in the Google Prediction API. So we're calling this step 4, adapt. And this will stream new data to your predictive model. So this is actually implemented as a put call in HTTP. The path is similar to what we've seen before. It's training / the name of the model that you want to update with the streaming training. And so there's a couple pieces of information you have to put into the body. Think of this as a piece of the comma separated value format you did at the beginning. The first piece is the class label. For example, we're doing hashtag YouTube. This is a new piece of data someone's posted with hashtag YouTube. This is the true label of the data. This is what you're trying to say, OK, this is what the data should look like. In future predictions, this is the kind of the class label that's associated with this. So this is really like one line in the original training set. So you'd want to make this update every time you get a new piece of true data. The second piece is the comma separated value instance. This is the features of the new piece of data. In this case, it's a single text feature. I just saw this wicked cool video. So someone made a social media post with hashtag YouTube. And so since it's marked as hashtag YouTube, we actually know this is a real piece of data. So we're going to use this to update our predictive model. And when we do enough data like this, when people start posting stuff about YouTube, it's not necessarily tagged as YouTube, we'll be able to predict this, OK, this actually should be categorized under the YouTube. And then after that, we see the response from the HTTP. So let's look at how we can use streaming training in our content tagger application. So first, we're going to, so this adapt part of the application. As before, you have text inputs, which we're trying to make a prediction of. And we're going to have a new functionality called learn new hashtag. So first, let's put a piece of text. This channel's video has a lot of hits. And so keep in mind, this is with our old predictive model. We actually haven't done any updating yet. This is with the predictive model we had trained just before. So let's see what we get. So we get hashtag Android. This actually has very little to do with Android. But remember, the only tags we have so far are Android, Chrome, and App Engine. So this looks as much like Android as anything else. The predictive model really has no way of knowing this is YouTube. We've never even told that YouTube exists. So let's see how we can modify our application to quickly adapt to new data. And this will allow us to get better predictions. So we have a function, send update, which takes in a text snippet. This is going to send, we want this to send an update to the Prediction API to make an update call with a new piece of text input. And so we're going to use the JavaScript library. And the function call is called prediction.training.update. And so let's look at this a little bit more closely. You'll notice this resembles a lot like the underlying HTTP requests. And in any client library you use, it's going to look something like this. This is the JavaScript library, but as Max mentioned, we have a lot of client libraries already available. So the first piece is the name of the data. the predictive model that you want to update. So we're still using the same model that I just trained before, io11/mydata. Then the next piece, the class label. This is what we're saying the true label is. So we're going to grab that from the topic field. This is the piece on the HTML form. We're going to fill in ourselves. And finally, the common subject value instance, and we're just putting in that text snippet, which is the input to the function. And finally, we execute an update callback. So let's save. We're modifying our application. And let's go back to the content tagger demo and see what happens. So we want to learn a new hashtag based on a whole bunch of new data. So we've actually written a whole bunch of comments that look like YouTube comments. We're going to put hashtag YouTube and then updates. So we're going to quickly skim through the comments. We're just putting a whole bunch of data into the system. So for us, it was a little bit trickier. We actually wanted to put it all up in ahead of time. And so we actually did a little bit of work to actually list through them and do an update for each one. For your application, it's actually much simpler. As soon as the data is created, as soon as the users clicked on the link or bought the item, you say, OK, this is a real prediction. And you can just put that together, put it into a JSON, and call your client library, and away it'll go. So we've updated our predictive model using this new hashtag. So let's try the same string again. This channel's video has a lot of hits. So we're going to run prediction. And before we got hashtag Android, did you update? Oh, you have to refresh the page, I think. So we didn't actually refresh the page. And so notice he actually live coded this. So we're going to try this again. OK. So as I said, we've done an updates. We've gone through all these pieces of new text. And now that all the text has been, so each piece gets sent to the Prediction API, and we say this is a new instance. And we're really updating our predictive model. So let's try again on the text string. Great. So we've we've predicted the new hashtag YouTube. Remember, the predictive model, before we did this update, didn't even know what YouTube was. So we can actually add new class labels as you're updating your model. And that's not the only reason you would want to do this. Even if there's no new class labels, as I've mentioned, you can just keep on putting more data, and the model is just going to learn more and more about the world. And it's just going to improve. It'll work better for more users. It's just going to get better over time. So you can see how you can use this to improve your application. I just want to give a couple of comments on how you may want to use streaming training in your application. First of all, when you're adding new data, you really should add all the data that represents the world. So you shouldn't actually just be putting one piece of new data, like one new class label, whatever. You really want to be throwing all the data as much as possible together. So don't just say, I want to learn this new type of information, because that could really bias the model. The model is going to start thinking, oh, OK, this is what it looks like now. So you really want to have as good of representation as possible. And that actually makes your life easier, because you really just want to naively just put the information in there. And a second bit of information about when you're using streaming training is the predictive model isn't going to work with a very, very small amount of data. Especially the larger your model is, you need more and more information for it to learn. So don't just send a couple instances, expect it's going to work magically over across all YouTube comments. If you want it to recognize YouTube really well, you have to give a lot of comments. So really give as much comments as you can, or as much input as you can across all the different types of data, and streaming training is going to work much better. With that, I'm going to turn it over to Max, who's going to talk about another really exciting new feature we're talking about today. Thanks a lot.
So I hope that you are all excited about this new feature we just announced, streaming training. And it makes your life much easier to adapt. Whatever the user can change, data can change, but this really makes it easier to incorporate predictions and make your app smarter. Before I tell you another new features, I want to have a quick hands. Like, how many of you are already in our beta group and have used Petition API? OK, some of you. I'd like to take this chance and really thank you for using Petition API as a beta users. We get a lot of good feedback from you guys. And one of the feedback is they want to make apps smarter and also faster. So Petition API is easy to use, just simple 3 steps. It sounds easy. But say I'm a ice cream e-commerce website. I know how to sell ice cream sandwiches. I know people, when they buy Manila, they also like chocolate. I can learn this, use Petition API. But I know nothing about sentiment. But what if I want to, when people talk about my ice cream sandwich websites, I want to know, are they excited or not? Are they happy or not? So how can I incorporate this in our e-commerce website or my social media monitoring? So today we are very happy to announce a new feature in Petition API called Hosted Model Subscriptions. And the idea is that at Google Petition API, we are going to host a bunch of different models. And those models, those predictive models are pre-trained. And you just subscribe to them and you can use. So that's why the name is hosted models, and you subscribe to the hosted models. So what does this mean to you? So let's go back to the ice cream sandwich e-commerce website. So you don't have expertise, you don't know how to do sentiment analysis, that's fine. But there are a lot of people who are experts in analyze piece of text. They already collect the data. So why can't you just stand on their shoulders and leverage their efforts? So if there is a hosted model about sentiment analysis you can right now subscribe to, it's much, much easier for you right now. You can just add that functionality in your web apps or Android apps and make your apps can do sentiment analysis. So that's, we really want to offer this feature to make your apps smarter and faster just right now. So there are several the reasons we want to do this. So first, we want to build this hosted model subscription. Is mostly of developers. Today we are going to give you some examples hosted models. But really, we really want to hope this is a marketplace for developers. The hosting models should provide and developed by the developers. And also, we really want these hosting models is driven by the developers' needs. So if you develop some apps and you're really looking for some hosting models, some pre-trained model for your needs, say for example, I really want a good spam detectors that can filter all the inappropriate content on my forum. So I really want a detector can do that. So really if you have those needs, please let us know. There's a sign-up form on our document websites, and you can tell us, I really want this hosted model. On the other hand, if you have an awesome model you develop for yourself, say you already have a very good spam detectors working very well for yourself, and now this is a chance for you to share with other developers. And you can also monetize on these hosting models, on the models you develop using Petition API. So as you can see, this should be a marketplace for people looking for models and for people who want to sell their models. And the third bit is, the whole reason we want to do this is for the developers. We really want to make your apps smarter, but we also want to make it very easy. Right now, you don't have to collect training data. You can stand on other people's shoulder. They already do the heavy liftings. Why can't you just stand on their shoulders and use hosting models? And you can start to use, you can make a prediction right now in your apps. So I'm going to show you, let's go back to our web app examples. Before I do that, I forget to tell you the syntax. The syntax, again, is very simple HTTP call. And the syntax is similar to the prediction call we just introduced before. The only difference that instead of saying training, here the syntax is prediction /v1.2, that's the version number, and /hosted models. So instead of saying training, you specify, hey, I want to make a prediction against a particular hosted models. And you just append the hosted model name after that, and at the end you append predict. That means you want to make a prediction against a particular hosting models. And inside the body, it's just the same as before. When you make a predictions, you just pass a new data point, a new piece of text, and you send over to Petition API. And Petition API will take your input, look up the hosted models you specify, and give you a response. So as you can see, there's no training and collection data phase, you can just right now make a prediction against a hosting model. So I'm going to show you how we can incorporate hosting model in our web app demo. So remember, we collect a bunch of data on the social media and try to detect when people talk about App Engine, Android, or Chrome. But I know nothing about sentiment. I really want to know when people talk about App Engine or Chrome, are they excited or not? So I really want to do a sentiment analysis. So when as you can see in the middle of the box, when I type something there, I really want to send to Petition API. First, I want to know what a category this piece of text is about. But I also want to know, is this piece of text expressing any positive or negative sentiment? So how can we do that? Let's go back to our JavaScript examples. Again, I want to emphasize this is not just working for JavaScript. We have Java, Python, Ruby, and various libraries for you to use. So here, again, it's a very simple one function call you have to make. It looks like 4 lines, but it's just one function call. And the name of the function call is called prediction.hostedModels.predict. So inside this function call, you just pass 2 arguments. First, obviously, is the name of the hosted model you want to make a prediction against. So here we want to do sentiment analysis, and today we provide a sample examples called sample.sentiment. So the name, this sample.sentiment is a hosted model hosted right now at Petition API for you to use. You don't have to collect data. You can right now make a prediction against it. And the second piece of argument is the input field in the JSON format, and that's basically the input you want to send to Petition API, a piece of text you want to detect sentiment. So again, inside this predict function, JavaScript function, you see we make 2 calls. One is the one we make against our own historical data. The second one is the prediction call, but it's against a particular hosted models, and we want to get a sentiment. And then save it and go back to our web app and reload and see how it works. So this is a subscribe phase of our web demo. So we are going to type a piece of text inside this box. Say, I gave my mom a new Nexus S phone, and she really liked it. And let's press the predict. And it works. So on the right of the predict button, first you see there is an Android, and that comes from our own historical data we collect ourselves. And you also see another response from Petition API. It's positive, and that's the response, the category returned by Petition API against a hosted models that we don't have to collect data, but we can right now very easily incorporate this in our web app with just one function call. You don't have to collect data, and you can use right away. Let's just try something else. Say, I really don't like this music video. So suppose you get this piece of text from social media, and you want to know what this is about, and are people excited or not? And it works again. So the tag you see here is YouTube. And remember, the reason we can get YouTube is because Robert just showed you we adapt to the new piece of data. Before we know nothing about Android in the beginning of this demo. Now we learn this is about probably related to YouTube. And we also get a response from hosting models, and this is negative, somehow expressing a negative sentiment. And the hosting model detects this in the hosting model. So I hope by this point you all feel very excited and start to think how I can incorporate hosting models in your apps. If there is any hosting models you really want, please let us know. If you have awesome models you really want to share with other developers, please also let us know. With that, I'm going to hand back to Travis.
So some of you may actually have models that are built outside of the Prediction API, and we have one final thing that we want to announce, which is that we're also starting to support a open standard called the Predictive Model Markup Language, which enables you to import predictive models from elsewhere and then bring them into the API, either to share with others or for your own use. So you can see on screen how all this works. You bring in your model via the PMML syntax, and then we will make it available to you. So that's the end of our announcements, but I just want to get you guys thinking about some other ways you can use this system. So I know we talked you through a sentiment analysis example. You can also imagine, as we've also been talking about, having an e-commerce site, and as people buy things, building a large recommendation engine to show them other things they might be interested in. You can also imagine filtering inappropriate content, sexual content, other sorts of things that you don't want on your site. Whether users are going to stay with your site or leave it, churn prediction. The examples go on, so you can see 15 here, but there are many, many, many more. And I also just want to close by telling you what we've told you, which is that we've made it so anyone can access the API. We've shown you how you can make even fresher models through the streaming updates that Rob showed you. We've shown you that you can just drop in really expert predictive models using our forthcoming gallery, and you can try all these things today. So we look forward to both your questions and to seeing the applications you built with the API. Thank you all so much. We have, thank you. We have microphones on both sides of the room. Please speak into them to ask a question so that the people on the video can hear you and everyone across the room can hear you. I'll take one from there first because you were the first one up.
Okay, this is awesome.
Great.
I was there at the talk, last year, and I was trying to figure out how to do it. A couple of questions. One
Sure.
is that, do you have, can you, or have you used this for entity extraction? For example, if I take, let me give you an example. I go into TechCrunch. I feed take an RSS feed, feed all the articles, that's my learning data. Then I take to the Crunchbase and take all the list of companies that are represented and products that are there, and then that is my, the identification of what this learning data is about. Now I throw any new article, let's say from New York Times or from Inc. magazine or something like that. Can it come back and give me a list of companies from this article?
So, so the way you would structure that sort of problem would be you would take the TechCrunch text and then have the output, the prediction you're making in the training set, be the actual companies contained within that article. We can talk more about how exactly that goes through, but that's conceptually how it would work.
Okay. And similar things can be done for products and technologies and events and stuff like that.
Yeah, we'll be here all at the end, and I'm happy to talk you through that all in detail if you don't mind.
That's great. So
great, awesome.
This changes search quite a bit, right? There are interesting implications on search for this.
It changes a lot of things, so we look forward to seeing what you guys can build. I'll take the question here next and bounce back and forth from there.
So will there be like complex data types or like video or sound or music?
You guys want so much. We're working on it. It would be great to hear how exactly you want to use it so that we know which ones to prioritize first. So let's talk at the end, and we can talk through how exactly you want to use it, if you don't mind.
Okay, thanks.
Great, thanks. Over there.
Yes. Is there like a feedback mechanism? So you show like a list of results. Well, I actually don't show a list of results, but you show it if it's positive, negative, or you show a tag. What if the user feels it's wrong?
Yes.
Does it go back to the system?
So a few things. We actually do show a distribution across all possible categories. So we didn't show that here because you actually have to look at the syntax of the JSON, and it's sometimes hard to parse. We actually show a distribution. So if you have 3 categories, A, B, and C, there is, A is 0.5, B is 0.3, C is 0.2, that sort of thing. And you had a second part to your question. I blanked on it. I'm sorry.
Yeah, if the user doesn't think your prediction is right, does it go back to the system?
So that's why one of the many reasons why we enabled streaming updates, so that you can then do that and say, hey, this was wrong. We tagged this piece of comment or this comment improperly. Please retag it in this training set as being something else. So what you can do is you can take what the user has told you as being the label and reapply it through the update into the predictive model.
Oh, okay.
Yeah.
Also, another question.
Sure.
So the examples you have shown kind of just show classification, I guess.
Yes.
But is there like prediction on the, I guess Max kind of mentioned it, continuous value.
Yes, there is. Yeah, it's all documented on the website. Feel free to look there.
Okay.
Yeah.
Okay, thank
Great.
you.
Oh, no worries. I think we have time for one more question. Again, as I said, we'll actually be up here, so please come up and ask them. Yes, sir.
I was going to ask the same question, but I'll rephrase it a little bit.
Sure.
If a user thinks it's wrong, or he may think it's right, can the system learn? Because retagging is a little different. Can the current tagging be marked as, say, you guys, you didn't do a good job, it's wrong,
Yeah.
or it's right?
So the system runs on, well, I'll refer you to the engineering team so you can get a specific answer as to how it works. But basically, there's no way currently to provide sort of that negative reinforcement you're talking about.
Like supervised learning, that's what I'm talking about.
Yeah, we're primarily focused on positive reinforcement.
Okay, I see.
Great.
And second question, it's great that you allow to import our current model into yours.
Yes.
Would you allow to export?
So we use both publicly available and proprietary models. So we don't currently support export. If you do want to export your model, we can talk about that. That's something we've talked about internally. But we'll have to be sure to pull out the proprietary ones.
Thanks.
No worries. Thank you all so much. Those of you who are still here, we would be happy to answer your questions up here at the end. Thank you again for coming.